Hey guys, this is Mr. P. I'm out today. My grandmother passed away last night, so I'm having to do this video for you. It's kind of important that we move on. This is the last chapter of our book, and we just kind of need to push through it. So here's this video. This is the first part in differential equations. Make sure you get this worksheet from the sub. It's kind of a guided notes for this. I'm not going to read the text, but I want you to pause the video and read it yourself. I'm going to go through just the examples. So make sure you get this worksheet from the sub. Also on a side note, this is from a different book than our normal textbook. So your sub will also give you a new set of worksheets for the homework problems. So let's get started here. So when we have differential equations, a differential equation is just an equation that you can differentiate. And so, like we've learned with integrals, when we have the plus c, there can be multiple different solutions for them depending on our initial condition. So, if we have this differential equation, y double prime take away y is equal to 0, we want to see which of these, if any, or if more than one, can be a solution to it. So since it's y double prime, we need to find the second derivative. So here, for example, A, if y is equal to sine of x, then y double prime is equal to the cosine of x. Whoa, I just messed that up really bad. If y is equal to the sine of x, then y prime is equal to the cosine of x, and y double prime is equal to the negative sine of x. So the way that we check and see if it's a solution is we sub it in. So let's sub it back into this equation here. So y double prime, which is negative sine of x, and we want to take away y, so take away sine of x. We want to know, does that equal 0? And so when we work this out, we've got a negative 2 sine of x's, and that does not equal 0. So that is not a solution. All right, let's look at part B here. So again, we need to find the second derivative. So if y is equal to 4e to the negative x, well, y prime would be negative 4e to the negative x, and y double prime would be equal to 4e to the negative x. So again, just like we did on example A, we're going to sub back in. So 4e to the negative x, take away 4e to the negative x. Does that equal 0? And that is true. 0 does equal 0. So this one is a solution. All right, let's do one more here. What about, this is question C. What about, let me move it over here. What about if y is equal to c times e to the x? Well, then y prime would have to be c e to the x as well, and y double prime would have to be c times e to the x as well. So again, subbing in here, y double prime, that's c e to the x. Take away y, which is c e to the x, should equal 0, and it does. So that as well is a solution. So what you saw here is we actually had two solutions. And that's like we've talked about, that c can be infinitely many different numbers when you have that constant. So this is what's called a general solution. Now when you actually figure out what the constant is, you can find what's called the particular solution. And to do that, you need to use the initial condition, which we've done a little bit already with integrals. Let's going on to example 2. This one says that verify that this that c times x cubed is a solution to the differential equation x y prime. Take away 3y is equal to 0, and then find out what it would be, find the particular solution if you've got the initial condition y is 2 when x is negative 3. All right, so again, the first thing we want to do is, since it's got y prime in it, we need to figure out, well, what's y prime? Well, if y is equal to c times x cubed, then y prime, that would have to be equal to, remember c is just a constant here, so we're just using the power rule, 3 times c times x squared. So let's plug in here to verify. So sub in, I mean. So x times y prime, which we just figured out, is 3 times c times x squared. Take away 3 times y, which we know will sub in is c times x cubed. Does that equal 0? And then when you multiply this all out, you get 3cx cubed. Take away 3cx cubed. Does that equal 0? Yes, it does equal 0. So then we can use our initial condition. So to use our initial condition, we just use this general solution. So y is equal to c times x cubed, and remember we call that the general solution. So we're going to plug in here. 2 is our y, should equal to c times negative 3 to the third power. Well, negative 3 to the third power, that's negative 3 times negative 3 times negative 3, which would be negative 27. So 2 is equal to negative 27 times a c, which means that negative 2/27 is equal to c. So now that we know what c is, we can find the particular solution, which would be y is equal to negative 2/27 x cubed. And we call that the particular solution. In the essence of saving time, I'm going to stop this one here and continue a second video.